Hello, this is an example of a few different methods of adding fractions. So in the first example, we have 1/4 added to 2/3. They have different denominators, and so there's a table method. It's very similar to the area model method, except that in here you draw your table that has a area model of or a number of units that is four and four wide, three high. You could also flip it. Basically, this is just giving you the um, least common multiple of four and three, which is similar to when we were multiplying by four and by three to get our area model previously. And so what you do now is you put a little tally in each square that represents a fourth. And then you do the same thing. You draw your model again and you show what 2/3 would look like. Use a different little marker. And then when you add them together, you put all of that together inside of your table. And then you separate them. And so that each little tally has its own unit or own unit box. And then you count how many are filled out of the whole. So it'd be 11/12. Another method I found was a tally method. I um, what you do is you are instead of using numbers, you use tallies and you keep adding your groups until you get to the same amount in the denominator. And so you can see here that I added 3 1/4, or I added 3 ones, and then I added three groups of four until I got to 12, because when I did the same thing with the 2/3, I had to add four groups of three until I got to 12. And so that brought me to 8 ones on the top. And so then you just add up all your tallies and you keep your same denominator, and then you have 11/12. And then I picked a few different fractions to practice combining with the algorithms for decimals and whole numbers. So I tried the partial sums method. Here, what you're doing, well, first I just used the algorithm we built for um, making like terms for my fractions that did not have um, common denominators. And then I added started with my whole numbers, added them together, and then added my fractions together, and then added everything at the end to get 3 and 17/20. This is very similar to the decimal version where you're taking each place value, adding them together first, and then adding everything up in the end. And this uses the commutative property. And then I used the column addition method, kind of. Again, I just used the standard algorithm we built to get my common denominators, only now I have improper fractions. And so then when I added all of the numerators together, it gave me 30. Oh, I took the 27 and the 10 and I added them using the column method, starting with the ones and then going to the tens. But there wasn't really anything to regroup or combine, so it just was a simple addition. And so I was left with 37/15. And then I just decided to leave that and not change to a mixed number. Then I tried the a some number line work, and this number line method was very complicated. There's really no point in me explaining it because it is not going to be helpful to anyone. I didn't even like it. But here I just did the traditional, um, or not traditional, the another alternative method of the uh, butterfly method or the cross multiply, where you just multiply the denominator and get your multiply denominators and get your common denominator, and then you cross multiply, or I think people say butterfly method, and you get your two terms to add in the numerator. And that gave me 37/15 or 2 and 7/15. And with my wild method down here, the number line, I also got the same answer. Another number line method you could use is you create two number lines, and one has uh, for example, 1/4 plus 2/3 has 1/4 on it. And then I indicated where 2/3 were. And then to find out how much to add on to at least one or the other, then I looked at, okay, well, what if I split this into thirds as well, and then split this into fourths? And then I could see I now have like um, partitions. And so I could add these three, which ended up actually being twelfths, add these three twelfths onto this 2/3, and then I end up with 11 twelfths. And I believe that is all of the work that I found.